I noted, we've already done this. This is analogous to distributions of categorical variables. Now, over here we have variable 1 on one side, and then we have variable 2 on the other, and we list their responses to these questions right here. Now the questions, the how many responses can be 1, can be 2, can be 3, can be 4. There has to be at least 2 responses, but it can have more. And so this is, option 1, option 2, option 3, option 4, option 1, option 2, option 3 in terms of responses. And then we have the totals over here, which we refer to as, the marginal distributions, which would be the totals for them. These would be the row totals, and these would be the marginal column totals. And then of course this is the total, as we often refer to it. How many, this is the amount of who. Now, when doing these problems, it's very important to understand the population. And a lot of this, like I said, is the same thing. So when we're doing the probability, so the probability is always equal to the number of outcomes over the total population of interest. Now, it's this part about the population of interest that can confuse some people. So sometimes I might say something like, find the probability of a student, all right, and these might represent all, the who, they might represent everybody here is a student. But then I might give you one of the responses. So I say, what is the probability that a male, all right, now we're talking about specifically the males, and those ones we call conditional distributions when we call it. And for now, and here we call them conditional probabilities. And I will show you the notation for those ones. All right. So I want to be careful. Determine if denominator is total population or if a conditional population, i.e. of males or of students versus of males. Okay. Best thing here is to do an example. Now, the first type of problem will be basically the same type of example that you saw in the past. I'm going to give you the frequencies. And as before, I think I've actually given to you before, I can give you the frequencies or I can give you the relative frequencies. All right. And so sometimes the numbers inside here are going to be, inside the two-way table will be actual, 10, 5, 15. And sometimes they're like 0.1, 0.2, 0.4. But the properties stay the same. So let's look at an example. And this data comes from my data from last year. And the question was about gender and clothing. So I did a survey for my students last year, and when I asked them about gender, and the options here were male or female, and I asked them about their clothing specifically, were they wearing a jacket, a sweater, were they classify a jacket, sweater, or a shirt? And they had to choose one of them. All right, so they had to state that they were wearing a shirt, a sweater, or a jacket, and we classify it for some people like, well, it's not a jacket or sweater or a shirt, and we were like, well, we'll define that as one of them. All right, so we calculate it, and in today's problems, I'm going to give you the base of these tables. So the base of this table would be male, female, jacket, sweater, shirt. All right. So I had 20 AP Stat students. And so as such, the responses within here should add up to what?
20.
20, very obvious there. And the responses that I got, and this is all given for you in tonight's homework, you'll see that these are given. 6, 1, 6, 2, 2, 5, and what does the other one have to be? What does the last one have to be? And this is going to be more important for like tomorrow.
4.
It has to be 4, okay? Because the total, all these numbers have to add up to 20. All right, so we were at 16, so the last one had to be 4. So I just want to kind of point that out. That's something that'll be helpful tomorrow. Now, step 1, or I'll call it step 0, is to fill in two-way table. Now, I say this is step 0 because in today's problems, it's already given. All right, so you don't have to fill in a two-way table because it's already there. Now, the first step that you will do from here is to fill in the marginal distributions, or sorry, the marginal totals / probabilities. So what we're going to want to do is we're going to want to extend this table, and we want to have the totals. The totals. Now we know the bottom right number should be 20. The numbers in the margin should add up to 20. We add straight up, straight down, left to right. These two numbers, and this is going to be important once again for tomorrow, these two numbers add up to this. These two numbers add up to this. These two numbers add up to this. These two numbers right here. We add the rows. We add the columns. All right. So what do I get on the bottom left first? Where do I go from there?
3.
Then
11 and 6.
All right. And just to confirm, 3 plus 11 plus 6 is 20. Boom. I'm happy. Top right numbers?
9
and
11.
9 and 11. Now, some questions will be like yesterday's questions. All right. So now we just do these questions as we normally do. So question A. So all these questions will be like, what is the probability that a randomly selected. So you see the vocabulary changes a little bit, because last time I said what percent. I said something like what percent are. That's what we did in chapter 3. What percent? But now that's just a probability that if I randomly select, what is the probability that a randomly selected ... So every one of these questions is a randomly selected. We're randomly going to select. Okay? So question A. What is the probability that a randomly selected student is male? Now, who am I looking for? Who am I choosing from? What is my population in this question? I want to always identify the what. So when I do these problems, my answer is always the what over the who. Okay, so that's where it gets tricky. So who am I asking here?
All of the students.
All of the students. So this is my who, and I'm asking of those students, the who are male. So that's the what. So how many students are there? That tells me my denominator. So we say the probability that a student is male, now that we know this new notation, is equal to what? How many students are there?
20.
And of those 20, how many are males? Now this is a marginal question. This is a marginal probability.
9.
9. We just look to the far end. So marginal. And that's my answer. 9 out of 20. Same thing that we've done. Like I said, it's the same thing that we've done. It's not meant to be trickier. What is the probability that a randomly selected student is wearing a jacket? Okay. Once again, my population, who is I'm asking about students. So using the notation, I would say the probability of a jacket, and I could say J because there's only one thing that says J. And if I want to spell the whole thing jacket, that's also fine. The probability of a jacket wearer, I selected jacket wearer, would be
3 of 20.
3 total jacket wearers out of 20. So this is a column, another marginal, and so we get 3 over 20. Conditional probability, mostly for the notation. You could add the following question, you can answer it without me actually doing this part. But understanding the notation that we're going to use is very important. So conditional probability is a subset of the population. In other words, one variable response is known. Okay, so we say this as we call these given. So given, what is the probability of B given A? Okay, so we know A is true. Now, I could also state this as the probability and A is B. So there's different wordings. I know when I say it probably probably an A. I know that they're A. And I'm asking, what is the chance that this A is B? The notation that we use is the following. It's the probability of B given. We use the upside down. This is given, conditional of A. So that little symbol, that little vertical line means given or conditionally on or condition. I'll just say condition. It might make it a little easier. So it's given or condition A. This probability is equal to the probability of B and A over, or actually I want to do A and B. It doesn't matter if A and B or B and A, they're the same thing. Divided by the probability of A. That's the formula. All right. We've done that. This will be more important for the second part of problems I'm going to do, but it's the same thing that we've done before. And I know it looks a little bit different, but as you hear me say the things today for this next example, you'll see. So question C, what is the probability that a randomly selected male is wearing a jacket? So we want to, we're selecting a male. Does that make sense? And did I hear someone's mic go off? I had a question?
Oh, sorry. No, I was going to answer.
Oh, hold on. Before we do that, I want to say that now I know, and the key thing here is that this is a known. This is a given. We know they're males. All right, so when I find, this is asking me the probability that they're a jacket wearer given they are male. All right, so this is what the question is actually asking me. What's the probability that they're wearing a jacket? I'm still asking about jacket wearers. I'm really interested, are they wearing a jacket? But I don't care about all the students. I'm only looking at the males. Of the males, what's the probability I select a male, someone who's wearing a jacket? Of the males. Well, my denominator is no longer 20. What's my denominator?
9.
9. Now, the interesting thing here is that my numerator still stays the same because I'm only looking at my males and I'm doing jacket wearers. So most of you are like, oh, I know the number I'm going to use is this one right here. But now that's male and jacket. So that's why we say this is male and jacket. So I would get 1 over 9. Now, if you're asking, well, didn't you just show me something about probability of A and B and so forth like that? Well, yes. This is the same thing as the probability that I randomly select a student who's wearing a male end jacket would be 1 out of 20 divided by the probability that I select a male, which is 9 out of 20. And you can see these 20s cancel each other out, and I get 1 over 9. Now, that's not how we should do this problem, but basically the math and the notations and the rules still apply. So it's 1 over 20 over 9 over 20, but if we really want to just solve this like we did in chapter 3, it's 1 over 9.
Wait, within the parentheses, does it matter if we put jacket or male first?
It does, because the next question, and I'm just going to write the whole thing out, all right? What is the probability of selecting someone who is male given that they are wearing a jacket. I wanted to word it differently because the way they're written, it's a lot of like English language, and it's like, all right, what do I know? What do I want to find out? So I know this one's very much more explicit. I know they're wearing a jacket. So this question is asking me, what is the probability that they are male given that they're wearing a jacket? So this is the opposite way. The first one with jacket given male, now it says male given jacket. I know that they're wearing a jacket, which is the probability of male and jacket over the probability of jackets. However, when we do this work, we're probably not going to utilize probabilities in this instance. I know that this answer is, how many students are wearing jackets?
3.
3. And technically it's 3 out of 20 for the probability. How many males are wearing jackets?
1.
1. And if you had wanted to, and you wanted to say that this was out of 20 and out of 20, and therefore they cancel each other out, that math always happens. And so we get an answer of 1 over 3, which is a far cry difference than 1 over 9, much higher. You're more likely to select a male who is, given that they're wearing a jacket, than selecting a jacket wearer given that they're male. So they are different. And that's going to be very important. That part right there will be much more important for Monday's lesson. So in this problem, I gave you the frequencies. Now the next one, I'm going to give you the relative frequencies. So it's the same problem, but now you basically have to, the answers aren't just going to be numbers. You're going to have to do the work out, and you should have a final decimal number on this next one. So in this next exam, first off, any questions about these ones before we move on? Yeah. So here's another example. In this example, I have for, my class was juniors and seniors. So I asked, I surveyed my AP Stat class of who is a junior or not, and if they study for at least 2 hours a night or not. So the question is, are they a junior? So all my class students were either juniors or seniors, but I'm going to classify them as juniors and not juniors. And then if they studied, if they classify themselves as studying 2 hours a night or are not. And it was a random question. I was just like, and so my results were as follows. Juniors, not junior, they studied or they didn't study. Now this is going to be much more applicable tomorrow. Tomorrow you have to create this based on the information I give you. Today I'm going to give it to you. And so my responses, I found that 28% of my students, right, were here, 0.28, 0.12, 0.02, and 0.58. I'll put the zeros in front. So these were my responses. These were the probabilities. These were the relative frequencies of the responses. Now, from this table, I can answer the very first question. What is the probability that I randomly select ... the first question being a junior who studies? What's the probability I randomly select a junior who studies? I'm not trying to trick you. So the probability that they are a junior and they study is equal to what? This is I am not trying to trick you here. It's very obvious. Sorry. I know why you're confused, okay? Because the who part. The way the wording is, it's the same thing that says it's an and. I could have worded this one as a student who is a junior and studies. I could have worded it that way. I know the language part of it. I'm not telling you that I'm still randomly selecting, but I randomly select a student. It's kind of inferred that they're a student and that this is a student who's. I randomly selected. I guess I should say a student who is. That might be a little bit better. So, what's the answer in this case? I can guarantee you, half of you that are of those European that are in here with me right now that are focused on this, at least half of you, what you think the answer is correct. Anybody? Could type it just as a direct message to me. Your thoughts. It's fine. Are we there? I'm looking at my screen and volume, and it looks to be going up. So I believe there's still connection, right? I need a response. Anybody, any response? Let's get something going. I'm not going to move on until we get something because this is as easy as an answer that I could possibly almost give you on the AP exam. It's that obvious.
Wait, so probability of, is that a J or S and
It's a J.
S?
Yeah. A junior and a
Wait,
senior.
is it a J or S?
That's a junior
Oh,
who
okay,
studies.
okay. 0.28?
Yeah, 0.28. It's the most obvious answer I could possibly ever give you, class. 0.28. Or junior in studies. Right there. Junior in studies. That's the junior and they study. Boom, that's it. So when I'm just in this case, I'm asking you a question about specifically about these probabilities within here. This is just a normal probability two-way table question. B, or question 2. What is the probability that a randomly selected student is a junior? Now, for that, this is where I want to probably go back, and if you haven't already done so, you might have want to fill in the totals, even though it wasn't given. So I get a 0.4, 0.6, and 1, like I should, 0.3, and 0.7. So what's the probability I select a junior? Now this is a marginal probability. Now there's no dividing. That's the thing that's about these ones. There's no dividing, at least in these basic problems, and finding the answer. So what's the probability that a student is a junior?
0.3?
0.3. That's it right there. The answer is just right there on the table. Then we get to the more trickier ones, and it's the last one I'm going to leave. What is the probability that I select a junior, sorry, what is the probability that a student studies given that they are a junior? So in this question, I'm asking you about the probability of studying given that they're a junior. So I know they're a junior. What's the probability that they study? Well, this is the probability that they study and are a junior divided by the probability of them being a junior. So now on these problems, this is a conditional probability, a given. And these ones I must divide. There's no way around it. I have to divide for here. So, well, we've already got the first part. What's the probability that there is they study and are a junior? We already know that one.
0.28.
0.28. All right. And we're going to divide that by juniors. What's the percentage or what's the probability that they're a junior?
0.3.
0.3. And it was actually given to you in that order specifically for to get this one. And so 0.28 divided by 0.3. There is a lot of juniors who study. All right. There were a lot of students who study. So 0.28 divided by 0.3 gives me 0.93. It's 33333, but 0.93 is good enough. That's what you're going to have for your homework. That's what you'll be doing. I've given you two different tables. Now, if you look at the homework, it says like 6, 12. So it jumps from 6 to 12, and then it comes back to, I think, 8. The reason for that is because problem 12 is a follow-up to question 6. So I'd rather you just do both of them together and then do the other one. So do them in the order of what they were assigned, because it says using the two-way table or using a table from problem 6. So you want to be able to do them just in that order. If you want to do 6, 8, and then the 12, I think those are the 3 problems that I give you. Then just do them in numerical order. but I suggest that you do them in the order I gave. Feel comfortable with this because tomorrow what I'm going to do is I'm going to give you the information and you're going to have to create this table. All right. So the table won't be provided for you. You're going to have to be able to create it based on the information. And that's what we're going to focus on tomorrow. And then the follow-up questions are all going to be the kind of the same as the questions that we were asked here. That's what I have for you for today. Have a good rest of your day. I'll see you tomorrow.